Hello, in this video we are going to be solving a Bernoulli differential equation. First, what is a Bernoulli differential equation? A Bernoulli differential equation is an equation of the standard form dy ds plus p of x y equal to q of x times y raised to n such that n is different from 1. That is, this equation is non-linear. To find solution of any Bernoulli equation, either of this form, we first change the dependent variable y to z. So our z is equals to y raised to 1 minus n. After these two things, this equation now gives a linear differential equation in terms of x and z, which can then be solved using integrating factor method. So let's solve this equation now. By comparing, you will see that q of x equals to x, this is y, n is equals to 2, so we have n equal to 2. Let's plug this value of n into this. We simply have z equal to y raised to 1 minus 2. So z is equals to y raised to minus 1. Differentiating this with respect to x, we have dz ds equal to minus y raised to power minus 2 dy ds. Because y is a function of x, this means that if we divide both sides by minus y raised to power minus 2, we simply have dy ds equal to minus y squared times dz ds. Take note of this. The next thing we have to do is to replace this dy ds with what we have here, minus y squared dz ds. So we have minus y squared dz ds minus 1 over xy minus 1 over x times y equal to the right hand side sy squared xy squared. Let's divide both sides by minus y squared, so that gives dz ds. This becomes plus 1 over x times 1 over y equal to minus x. This means that dz ds plus 1 over x times, suppose we want this y to be at the numerator, it becomes y raised to power minus 1 equal to minus x. But we already know that z is equal to y raised to power minus 1. Let me show you. From this line, z equals to y raised to power minus 1. This implies that we have dz ds plus 1 over x times this, which is now z, equal to negative x. You will see that this is a linear differential equation in terms of x and z. We cannot solve this using integrating factor method. Integrating factor method says if is equal to e raised to integral of p of x ds. What is p of x here? P of x is 1 over x, so this gives e raised to integral of 1 over x ds. If is equal to e. Integrating 1 over x with respect to x, we have ln x. This is equal to e raised to ln x is what? That is x. That means our integrating factor is equal to x. The next thing is to multiply this equation by integrating factor. So we have x times dz ds plus x times 1 over x times z, 1 over x times z equal to x times minus x, that gives minus s squared. So we have x dz ds plus s cancels x, we have z left equal to minus s squared. This means that this whole left hand side could be written as d ds of zx equal to minus s squared. That is, by product rule, you will have this back. Now, let us integrate both sides with respect to x. So that becomes zs equal to integral of minus s squared with respect to x. Zx is equal to integrating minus s squared with respect to x. We have minus s cubed over 3 plus k, constant of integration. Let's divide both sides by x. Doing that, we have z equal to minus s cubed over 3 times 1 over x plus k divided by x. Z is equal to s cancels 1x from here. We are left with 2. So we have minus s squared divided by 3 plus k over x. But z is equal to y raised to power minus 1. You should remember this. This implies that we will now replace this z with y raised to power minus 1. So we have y raised to power minus 1 equal to minus s squared over 3 plus k over x. Therefore, the required solution is simply 1 over y equal to minus s squared over 3 plus k over x. This is the required solution. That's it.